Hi everyone, my name is Grayson. In today's video I'm going to be explaining how a 3D printer works, starting off with how a 3D printer moves, how it extrudes, how slices work, and many more. But before this video starts, I'd just like to thank you guys so much for 300 subs. It's been a great journey for you guys, and I'm very happy that you guys allow me to be able to do this more often. But all I just want to say is make sure to hit the like and subscribe button. But now that I thank you guys so much for 300 subs, and I'm very thankful to all you guys, let's get on with the video. So the H2C heat bed is controlled by 3 threaded rods, and those 3 threaded rods are located here, here, and here. Now these 3 threaded rods are what controls the H2C's heat bed from going up and down, which creates the Z-axis. Now on the elegoo Neptune 4 Pro, this is completely changed. See, on the elegoo Neptune 4 Pro, the heat bed does not go up and down, it actually goes back and front, which is what creates the Y-axis. Now this is controlled by a small little belt on the back, and it is then hooked up to a motor, which is then hooked up to a little block that tells the motor whether to pull the heat bed back or front, whether what your model is. So now that we've learned how the heat bed moves, let's learn how the heat bed heats up. So your heat bed is located right under your build plate, and its main purpose is to generate heat. Now the reason why it generates heat is to create adhesion. See, if we didn't have adhesion, then your models or your objects would just go flying off your build plate whenever you try to print something. Now the way adhesion works is by generating so much heat to where it warps your model into sticking onto the textured build plate, so your models don't go flying off your build plate. So now that we talked about how a heat bed heats up and how a heat bed moves, let's talk about how a nozzle head moves to generate your model. See, on H2C there are 3 things that control the nozzle head: a belt, a rail, and 2 liner rails. Now those 2 liner rails are what brings the nozzle head back and forth, creating the Y-axis, and those belt and rails are what brings the nozzle head left and right, creating the X-axis. But now on the elegoo Neptune 4 Pro, it is switched. Instead of the nozzle head going front and back, it is actually going up and down due to the Z and Y axis being switched. So now that we talked about how a printer nozzle actually moves around to actually create the object, let's talk about how the filament goes through the nozzle to get extruded. So the H2C has 2 nozzles, one for the left and one for the right. Now both of the nozzles each have sensors that will detect if there's filament in there or if there isn't filament in there. Now you guys may be wondering, well, how is the filament getting in there? Well, the answer to that is simple. Can you see these tubes up here? Great. These tubes are called PTFE tubes, and they allow the filament to safely guide itself through the AMS down into a hole on the back of the H2C and safely down into your nozzle. Now once it has entered your nozzle, it gets grabbed by 2 gears that will then guide it down into a small hole and into your nozzle, where it will then be heated up and pushed out of your nozzle straight onto your build plate. So now that you guys know how the filament gets loaded into your nozzle and extruded, let me explain how it can be unloaded out of your nozzle. So you guys see this little tab here? Well, if you do, that's great, because this little tab here is what we like to call a cutter. Its main job is to cut the filament so it can be retracted back safely out of your nozzle and back into your AMS, so that we can use it once again to get great prints like this. So now that I've talked about how the H2C extrudes, let's talk about how the elegoo extrudes. See, the elegoo printer is a single nozzle printer, meaning it's only able to print 1 filament at a time instead of 2. Now just because it's a single nozzle printer doesn't mean it's different from other printers. It still has the same operation as a dual nozzle printer, just with 1 nozzle. And the way it works is really simple and not so different from the H2C. See, the filament first goes through a sensor at the top of the printer, and this little light tells us if filament in there or if it isn't in there. Now once it's gotten past that, it will go down into this hole at the top of the printer, and pressing down on this tab right here will allow the filament to go in and out of the nozzle. Now once it's gotten inside the nozzle, it goes down through 2 gears that will pull it down into a heating block just like the H2C. Then finally, once it's heated up, it will get pushed down and squeezed right out of your nozzle. So now that we talked about how a heat bed moves, how a heat bed heats up, how a nozzle head moves, and how a nozzle head extrudes, let's talk about how a 3D print actually gets 3D printed by using a slicer. So, slicers like Bamboo Lab and Kira are what helps our 3D printers to understand how to 3D print your object. Now, if we didn't have slicers, it would be really hard for our 3D printers to 3D print our objects due to the fact that we won't know how many layers are in it, how to print it, and what it looks like. So right now I'm going to go into my Bamboo Lab slicer and I'm going to show you guys a few settings and tools that can help you guys better understand how a slicer works. So once you have entered into your Bamboo Lab slicer, you'll notice that there's going to be nothing on your build plate at all. Now a reason for this is because you have not imported anything on there. Now a way you can import is by going from here to File, which is up in the top left corner, and then scrolling down to Import, and then pressing this button, which will open up your file manager. Now once you have opened up your file manager, you can go to downloads, and once you're in downloads, you'll notice that you may have a few files, whether or not you have downloaded the model or you have not downloaded the model. Now another way that you can open up your file manager a lot quicker is by pressing Control I, which will then open up your file manager a lot faster, or just by clicking this add button, which is up in the toolbar all the way to the left. As you can see, it opens up your file manager a lot faster. So now that I've showed you guys how to import files from your file manager into your slicer, let's talk about how each different setting here affects your model by changing how strong it is or how good it looks. So to begin, we're going to be starting off with quality, which is located right here all the way to the far left of your tab. Now quality has 7 different sections that have different settings in each of those sections. And the first one is layer height. Now layer height is how tall or short each of the layers are on your model. Now if you want to have your prints coming out smoother and cleaner, you can lower your layer height number to say 0.1 or 0.2, and it will make it a lot harder to notice those layer lines, making it a lot smoother and a lot cleaner for quality prints. So now that we talked about layer height and I explained how layer height works, let's go on to how line width works. See, line width is how thick or long each of your layers actually are. So if your default setting for line width were to be set to 0.25 millimeters like it is right now, your layer lines will be 0.25 millimeters long or thick. Now if this was set to 0.6 millimeters, your layer lines would be 0.6 millimeters long. But that may cause deformation on your 3D print and it will make your model look pretty weird. Alright, now pause. Hey, future editor here. What I'm trying to say in this clip right now is that if your line width is longer than what your model is supposed to have it as, then it may cause deformations to your model, making it so that the measurements of your model may be off by a lot. But now that I've said that, let's continue the video. Alright, so now that we talked about how layer height and line width, which are the 2 main settings in quality, affect your model, we're now going to switch over to the strength section and talk about the main settings in there. So the 2 main settings I'm going to be talking about is top and bottom shells and sparse infill. Now sparse infill is how much infill density that your model actually has. So if your infill density were to be set to 15%, then your entire model would have a density of 15%. Now if you come down here to sparse infill pattern, this is the different type of patterns that you can use to have your model used as infill. Now each of these different patterns give you a different strength level considering on which one you have. Personally, I would either use gyro or honeycomb, because honeycomb gives a nice clean structure to your model and is really resistant to different types of pressures. Now top and bottom shells are what the top surface pattern and bottom surface pattern of your model actually is, and each of these different layers, like I said for the sparse infill, give a different strength level to your model. Now the last 2 settings that I would like to talk about in the top and bottom shells section is top surface density and bottom surface density. See, top surface density and bottom surface density are the density rate for the top surface and bottom surface of your model. Now if both of these were set to 50%, then the top surface and bottom surface would be 50% density rate. So now that I explained the 2 main settings in the strength section, let's go on to the support section and talk about the 2 main settings that are involved in there. Now the 2 main settings that I'm going to be talking about in the support section are supports and raft layers. See, supports are basically what helps your model support itself if it has an angle that is impossible due to gravity. Another way you enable supports is by coming over here to enable support, clicking this little box here, and then a green check mark will appear. Now you can pick what type of support you want, going from normal to tree, and you come down here to style, and you can pick what style of support that you want to generate when slicing. Now, raft layers are basically an adhesive helper. It basically generates a giant raft on your model, and it adheres it to your build plate by using surface area. Now, if you come down here to layers, you can pick how many layers of a raft you want to have on your build plate, and you can come down here to raft contact Z distance, and you can pick how far you want the raft from your model to the build plate. So now that I explained all the settings inside your slicer, we can finally go on to the last thing that I want to explain in this video, which is model softwares. See, model softwares allow you to make your very own custom models for you to 3D print. In just a second, I'm going to be explaining a few things in Blender and how to work it. So, let's go. So we're in Blender right now, and I just want to show you guys a few tips and tricks you can use to create your very own model. So when you first open Blender, you'll notice that there is a cube, light, and camera. Now for this explanation, we'll have to get rid of the light and camera, and the way you do that is by holding down left click and dragging your mouse across the screen right over the light and camera. And once you selected both of these things, you can right click, come down here to delete, and delete both the camera and light at the same time. Now if you accidentally deleted the cube, don't worry about it, because if you press Shift A, it allows you to open up this tab, and when you press Mesh, you'll see a bunch of different models that you can use to edit. But for this, we're just going to be using a cube for showcase. Now there's a bunch of different tools you can use to edit this model, and they are located right over here to the left. Now if you select the Move tool, it allows you to move the cube around and position it in different spots. And this goes the same way for the Rotate tool, where it allows you to rotate your model in any direction. Now the final tool that I want to talk about is the Scale tool. See, the Scale tool allows you to stretch and expand your models as large as you want them to be. Now the last thing I want to show you guys is how you can edit in edit mode. See, if you come up here to object mode and select edit mode, you'll notice that there is now vertices on your model. Now if you want to be able to edit easier, you can come up here and switch it to either edges or faces. And if you select faces, it allows you to extrude it, scale it, and rotate it however you want. But now that I've showed you guys how to make your own model in Blender and how a few things work on a 3D printer, I would just like to say thank you guys all for watching, and I can't wait to keep making more videos of all. But with all that said, happy printing.